There has been extensive research to determine what guides viewer attention. It is well known that eye movement depends on the task at hand or the viewer's intent. We are also naturally drawn to faces in regions with high edge density and high contrast. Computer-based techniques for guiding attention can be as simple as directly marking up the image, or simulating the depth of field effect from traditional photography to bring different areas of an image in or out of focus. Eye tracking has also been used to determine what object in the scene the viewer is paying attention to. The red circle in the scene represents the high acuity region of the field of view. We can employ techniques such as eliminating previously viewed object to guide the viewer to look at the remaining objects in the scene. Eye tracking has also been used to guide attention in a subtle manner that has minimal impact on the viewing experience. Consider this hypothetical image. Suppose we want to guide the user to some region of interest A, but they are currently fixating on position F. Modulating the pixels in region A introduces a motion cue that attracts the viewer's attention. Modern eye trackers are fast enough to determine when the viewer's gaze is moving towards the target region, and the modulation can be terminated before the viewer can scrutinize it with their high acuity foveal vision. Gaze manipulation techniques have been shown to enhance spatial learning by improving the recollection of location, size, and shape of objects. Gaze manipulation strategies have also been shown to improve performance on visual search tasks. There are numerous studies which look at using expert eye movements for specific tasks, such as improving image-based algorithms. Feed-forward training in aircraft inspection, and the use of expert eye movements to train novices. Motivated by these observations, the goal of this work is to extend the concept of guiding gaze to real-world scenes. The system uses a head-mounted eye tracker and a projector. The eye tracking glasses provides a current fixation of the viewer. A visual cue is projected on a different part of the scene to guide the viewer's attention. This enables the viewer to make a saccade towards the desired object in the scene. In this system, SIFT descriptors are extracted from the high-resolution source image and the scene image taken from the perspective of the eye tracker. The red cross on the scene image indicates the current fixation of the viewer. 5% of the total descriptors in the scene image are matched with the source image to enable a computationally efficient matching algorithm. Green lines indicate correct SIFT matches and the magenta lines indicate outliers. The green cross on the source image indicates the inferred fixation from these SIFT matches. The red torus in the video shows in real time the gaze position of the viewer. The luminance modulations can be seen on the objects in the scene. The modulations begin with the cup and ends with the coffee can. This image represents the real-world gaze-guided scan path of a single subject. The inset in the image shows the labels assigned to each object in the scene. A pilot study revealed that on average, for a given sequence of 5 objects, only 1 error was reported. Furthermore, only 10% of the trials had more than 2 sequence errors. These results would suggest that it is possible to guide a viewer's attention in a real-world scene.